Hello guys, welcome to another video. In today's discussion we're just going to break down these questions on chemistry paper that was written in 2022. This is SDA or double science paper, which is similar to core for IG or BG triple. So you can still use this material to revise for your the core part, so that you get your basics together. All right. So the first question says, choose from the substances listed to answer questions A to E. So we have our substances there: fluorine, chlorine, biogas, calcium, nitrogen dioxide, ammonia, zinc, petroleum, tin, and copper. The instruction says each substance can be used once, more than once, or not at all. State which substance A most readily forms negative ions. Most readily forms negative ions. So what do we know? We know that what forms negative ions are going to be your nonmetals, okay? Your nonmetals. So when nonmetals react, they gain electrons from other substances in case of ionic bonding, right? So by gaining an extra electron, they become negatively charged, okay? They become negatively charged. Now, how do we determine which of these substances will readily, remember this point here, readily? So we have the two answers, possible answers. We have fluorine and chlorine. So we go back to our group properties, okay? So those two guys are found in group 7. So the group property says that the reaction increases up the group. The rate of reaction increases up the group. That means fluorine is more reactive, okay, or will readily form negative ions than what? Than chlorine. So the best answer, remember, we are looking for the best answer. So the best answer is going to be fluorine, okay? So the best answer is going to be fluorine. Next one, B says, is a component of both bronze and brass. It's a component of both bronze and brass. So we're just going to break down what makes up bronze and brass, okay? So we have bronze and then we have brass. Now these are two independent alloys. What is an alloy? An alloy is a compound or substance made up by combining a metal with another metal and or a non-metal, okay? For example, we have bronze, we have brass. Other examples include steel, which is a mixture of iron and carbon, a non-metal. So this is why it's important on that definition that we add a non-metal. So bronze is made up of copper and tin, okay? Made up of copper and tin. What about brass? Brass is made up of copper and zinc, okay? So here we're just looking for that common substance or metal in these two guys, okay? So the common substance there, or common metal that we find on both bronze and brass, is going to be what? It's going to be this guy here, copper, okay? So our answer is going to be copper. Remember, there need to be some sort of reason behind your answer. You don't just put the answer there because you feel like it looks nice or it's similar to what the question is asking, okay? All right, C says is a non-renewable source of energy. So remember, non-renewable sources of energy are going to be your fossil fuels, okay? Fossil fuels. So we in that list there, we're going to identify a fossil fuel so that it can be our answer. So the only fossil fuel that we have there is what? Petroleum. Petroleum, remember, is a fractionate of crude oil, okay? Crude oil. So we get this guy from crude oil. So when you fractionate crude oil, you get petroleum. So it's one of the products that you get from that, okay? All right, so our answer is going to be what? Our answer is going to be petroleum. Okay. D says does not react with cold water, but reacts with steam. But reacts with steam. All right, so what's going to react with water here? What's going to react with the water here? So this scenario here, remember it should always click that we are looking at metals, because metals, some are more reactive, some are less reactive, and some are not reactive at all with water. Okay, because it's one of those properties that we try to investigate. How do these different metals in different groups interact with water, whether you're looking water in the form of liquid water or you're looking at water with more energy such as steam. Okay, so here calcium will readily react with cold water, so it's out of the equation. Okay, and then we go to zinc and copper. Okay, so you go back to your notes, you'll remember that zinc does not readily react with cold water, but will react with what? With steam. Okay, will react with steam, whereas copper does not react with either. Okay, it doesn't react with cold water, nor does it react with steam. But there's something that might confuse you, is that sometimes you find those corroded water pipes. It's because the water that you have there is not pure water. Okay, so the copper will just be reacting with what? With the additives that are inside that water, your salts, your acids, etc., etc. Okay, so the answer here is going to be zinc. Zinc. Okay, let's just remove this. Okay, so the answer is going to be zinc. Okay, E says it's a pollutant from car exhaust emission. It's a pollutant from car exhaust emission. So the answer is going to be carbon dioxide. Okay, carbon dioxide. Oh, did I just say carbon dioxide? Nitrogen dioxide. Okay, nitrogen dioxide. Dioxide. Okay, so the answer is going to be nitrogen dioxide. Remember that in the car exhaust, we emit what? We emit carbon dioxide, carbon monoxide, nitrogen dioxide, etc., etc. Okay, but this guy here is the major problem. Okay, it's one of the major problem from car exhaust. Okay, because remember with carbon dioxide, naturally it's found in the atmosphere. Okay, it's naturally found in the atmosphere. So when it comes to nitrogen dioxide, it might be there, but in very, very, very minute concentrations. Okay, so the answer is that nitrogen dioxide. Okay, so let's continue to the next question. So that's easy, 5 marks there. Next question says the equation for the reaction of iron, metal, and oxygen is shown. Okay, so there's the reaction. It says that give the chemical name for this compound. Okay, so how do we do that? All right, so remember that when you have an ionic compound like this is a transition metal. So that means something that should click is that these guys can exist in multiple valencies. In other words, we have ion 2 and ion 3. So you need to be to make sure that you mention that in the chemical name. Okay, so we're just going to reverse this. So remember, this 3 belongs to the ion, the 2 belongs to the oxygen. Therefore, we are looking at ion 3. Okay, ion 3. So therefore, the answer is going to be that we are looking at ion 3, 1, 2, 3. Again. So ion 3 oxide. Ion 3 oxide. Simple as that. Then B says, Roman figure 1 says, state whether ion is oxidized. State whether ion is oxidized. Yes, ion is oxidized. Okay, ion, Fe. So you can either get a substance being reduced or oxidized. So in this instance, we are going to say that ion is oxidized. Is oxidized as the ion atom. Okay, atom loses electrons to an oxygen. Okay, an oxygen atom. Simple as that. So what's happening in this reaction is that you get the ion metal Fe. So this guy here is going to donate electron to the oxygen, okay, to the oxygen. Remember, when you have ionic bonding, in ionic bonding, this is an ionic compound. Remember, in ionic bonding, metals donate electrons, whereas non-metals receive electrons. And then the way we remember with relation to redox reaction is that we use this oil rig, okay? And then we say that oxidation is loss of electrons. What lost electrons there? This ion lost electrons, hence oxidation, which we agree with the statement at the top there. And then a reduction is gain of what? Of electrons. Okay, remember this only applies for the definition of redox in terms of gain and loss of electrons. Okay, all right, next question says, ion acts as a reducing agent during the reaction. Ion acts as a reducing agent during the reaction. Describe a chemical test to confirm that a solution contains a reducing agent. What do we use to test for a reducing agent? Remember that we're going to be using what? Acidified potassium permanganate. Okay, we're going to be using acidified. So the test is that we add, okay, to our sample, we add acidified potassium permanganate. Okay, acidified potassium permanganate. Okay, so you can just write the word, or write the formula there, but I'm running out of space, so I'm just going to write the chemical formula there. All right, so the result, what is going to be the result? So now when you introduce this substance, remember the color of potassium permanganate is purple. So the purple color for a positive test, so we're most of the time when we discuss the result, we are mainly concerned about the positive test. Okay, so for positive test, maybe let's just change the wording there a little bit, so that we put the for a positive test at the end. Okay, we put it at the end. Okay, so we're just going to say that purple color decolorizes. Okay, decolorizes for a positive test. All right, so to decolorize means to lose the color. Okay, so instead of started off with purple color, so when you decolorize, that means you are removing the color. So the purple color is going to turn to colorless or pale pink. Okay, or pale pink. So that is going to be the result. C says, in another reaction, ion reacts with aqueous copper 2 sulfate. Ion reacts with aqueous copper 2 sulfate. The equation for the reaction is as shown below. Okay, so we have the equation there. Name the name of the type of the I think something's wrong with that statement. Anyways, name the type of reaction. So let's just remove of the air. Okay, name the type of reaction. So this type of reaction is what? So what's happening here? We know that this ion replaces the copper. You see that? Or it displaces the copper from the copper 2 sulfate. Okay, it displaces. So this is going to be a single displacement. Okay, displacement reaction. Okay, reaction. So now there's a single displacement reaction and a double displacement reaction. So a double displacement reaction, it will be in an instant like this. So let's say you have ion chloride. Okay, ion 2 chloride, and then we react it with copper 2 sulfate like this. And then what's going to happen is that because of the reactivity series of metals, depending on the reactivity series of metals, one metal is more reactive than the other. Therefore, it displaces that other metal. So the ion comes here and displaces the copper, and then the copper now goes to where iron was, and then it replaces, not displaces, but replaces the position of the ion, so they swap. Okay, therefore this is going to result in a compound like this. So we're going to get copper chloride, copper 2 chloride, and iron 2 sulfate. Okay, now you see that the two ions, the two metals there swapped places. Okay, so this is why it's called a double displacement. Okay, this displacement of two metals. Okay, displacement of two metals. However, in our example here, we can see that only one metal displaces another metal. Okay, hence we say it's a single displacement reaction. Okay, we continue. The next question says, state two observations that are made during the reaction. What would you observe? Let's say you were doing the experiment. What would you observe? Okay, first of all, we have to go back to this part here and try to remember what is the color of copper 2 sulfate. Copper 2 sulfate is blue in color. What will be the color of iron 2 sulfate? It's colorless. Okay, or it's clear, it's colorless. Now if you're going to have an initial substance that is going to be blue and then later it changes color, that's an observation. Okay, so our solution, okay, so reaction mixture changes color. Okay, mixture changes color. We need to know those colors. So it changes from being blue to colorless. Okay, from being blue to colorless. I'm running out of space there, but we'll change color from being blue to colorless. And then the other thing that we observe is that we do have two solids, one solid at the beginning, the other solid at the beginning. So now those two particular metals have their own unique colors. Okay, they have their own unique colors. Okay, so this one, we know that the copper is salmon brown colored, or it's brown pink colored, whereas the iron is going to be silver to dark silver colored. Okay, so you can see that the solid that we're observing in our container, whatever container that you're going to be using, is going to be different. Okay, so you can also say that the formation of a pink brown solid. Okay, let's just solid. So those are the two observations that we can see during this experiment. Okay, so you have to put yourself in the shoes of you being in the lab doing this analysis. Okay, doing this analysis. All right, so let's continue. Next, the question says, aspirin tablets contains that acid. Each aspirin tablet contains 0.300 grams of acetatic acid. The molecular formula of acetatic acid is C9H8O4. Okay, then Roman figure 1 says calculate the relative molecular mass of the acid. Okay, so remember how you find your MR is that you just add up all the individual ARs of that are found in the compound. Okay, so it's going to be the sum of the ARs that you have in the compound. So we have 9 for carbon, so it's going to be 9 times the atomic mass number of carbon plus 8 times 1 plus 4 times 16. Okay, of course, I usually encourage you guys to put brackets here so that your calculator can do what? can give you the right answer. Okay, so this gives us 180. So for as per our syllabus, we don't really give units for relative molecular mass, okay, but units are there. But for our syllabus, it's not a must for you to give the units for the relative molecular mass. Then Roman figure 2 says, use your answer to A, Roman figure 1, to calculate the number of moles in 0.300 grams. Remember, the way to remember these formulas is to use these triangles, okay? Is to use these triangles. We know that mass is here at the top, mass, and then here we have MR or AR, depending on whether you are looking at atoms or whether you are looking at a compound. And then on the other side we have N for moles. Okay, so what are we looking for? We are looking for N. N is equals to mass over mr, which is equals to, the mass is 0.300 over mr, 180. Then you divide that. I've already divided it so that I don't waste a lot of time. So you're going to get a 0.0016666. Okay, so you can just round off that to 3 significant figures to say it's going to be 0.00167. Okay, yes, 67. B says a patient is recommended to take 2 aspirin tablets 3 times a day. Use your answer to A, Roman figure 2, to calculate the number of moles of the acid in the first dose of 2 aspirin tablets. Okay, so we are only going to be looking for the moles that we find in 2 aspirin tablets. So this is the moles, okay, the answer that we found in the previous question. We were looking for the moles in 1 tablet. Okay, so we know that 1 tablet, 1 T for tablet, gives us 0.001666. Okay, like that. And then 2 tablets gives us x, and then we can just cross multiply. Therefore, x is going to be equal to, now the question is, which number do we use? Are we using this number that we corrected to 3 significant figures, or we use the original? Always use the original so that you don't have any error carried forward. Okay, you don't have any error carried forward. So let me just remove all those markings so that our answer is going to be what? 2 times the 0.0016667. Okay, so the final answer is just going to be 0. Oops, wrong marker. Let's just remove that. So it's going to be 0.00333. Okay, so this 3 continues like that. Okay, so I'm just going to stop here, for time. Also, for significant figures, it's going to 0.00333. All right, but you can pause here so that you try to do to find the answer first, and then you continue the video so that you see whether you got it correct, and then the explanations will be there so that you understand how we arrive at the answer. Okay, all right, so those are number of moles. Remember, the units are already here, so we don't have to stress about that, but always check whether you are putting your units, especially for physics. There could be a mark for units. C says the average volume of blood in an adult human body is 5.0 cubic decimeter. Use your answer to B to calculate the concentration of the acid in this volume of blood after taking 2 aspirin tablets. So what we are going to do is that we write the formula that we need to do. Remember, what is concentration? Concentration is the number of moles per unit volume. Which volume do we have? We have this volume. Which moles are we talking about? We're talking about this moles. Okay, remember, with these types of questions, they're always referring to the previous question. Okay, so therefore our formula, concentration, is equals to moles over volume, which is equals to, the number of moles is 0.00333. Remember, you use the original, the one that is already in the calculator. So after punching the calculator, you don't clear that. You can store the the number there in your calculator so that you don't need to rewrite it again on the calculator, or you can just leave the calculator as it is as you proceed. Okay, all right, divided by 5.0 cubic decimeter. Okay, this is moles. Okay, this is moles. Now we need to write the units. So we're going to get 0.000666667. Okay, so I'm just going to write the three significant figures version of that answer. Okay, so this is going to be 0.000667 units, moles per cubic decimeter, because that's concentration. Okay, all right, we continue. Question 9 says a clinical disinfectant contains a compound X with the structure shown below. Write the molecular formula of compound X. Write the molecular formula of compound X. So now this is carbon chemistry. Okay, so there is a system in which we write these things. Okay, we follow whatever our syllabus is saying, and we can write in accordance to our syllabus. All right, so this is going to be C C3H7OH. Okay, OH. So that's the molecular formula of compound X. Okay, that's the molecular formula of compound X. B, Roman figure 1 says, name the homologous series to which compound X belongs. Now, whenever you see this, there's OH, it's screaming alcohols, okay? Alcohols or alkanols, okay? Alkanols. Okay, so therefore, the homologous series to which this guys belongs to is alkanols. Okay, Roman figure 2 says, write the general molecular formula of the homologous series to which compound X belongs. Write the general formula of the homologous series to which compound X belongs. Okay, what is the general formula? So the general formula is going to be Cn, okay, Cn H2n plus 1, then OH. So you can also test that out. Okay, you can test this formula to see whether you are going to get this this guy here, which represents this structure there. Okay, we can quickly do that. So if you put C, how many carbons do we have there? We have 3. Hydrogen H, so it's going to be 2 multiplied by the N, the number of carbons. So 2 times 3, that's 6, plus 1, that's 7. Okay, and then OH, and then you can just come here and manually count. Okay, we go up there and manually count. So this is carbons 1, 2, 3, which is this. Then we go to the hydrogens. Remember, we're only counting the hydrogens that are directly linked to carbons, okay, not the oxygen. So therefore it's going to be 1, 2, 3, 4, 5, 6, 7, which is what we have there. And then this is O, it's here, then the H is here. Simple as that. Okay, okay, let me just quickly remove this so that our working space is a bit clean. Okay, next the question says, name the compound with 4 carbon atoms in the same homologous series as compound X. Okay, so how it goes is that when you have 1 carbon for this group, you are looking at what? You are looking at ethanol. 2, you are looking at methanol. Wait. No, I think mix them up. Okay. So one is methanol. Yeah, I mixed them up. So 1 is methanol. Then 2 is ethanol. 3 is going to be propanol. Then 4 is going to be butanol. etc, etc. Now we're looking for 4 carbons. That means it's going to be butanol. Okay, butanol. All right, so we quickly remove that and we continue. C, it says compound X reacts with ethanoic acid CH3COOH to form an ester. Draw the structure of an ester. Remember, with ester, formation of esters, that is a condensation polymerization, okay, or a condensation reaction, whereby you react two of those molecules and you form a small molecule and then a larger chain there. Okay, so to draw the structure, basically you just copy this one and then you draw this one side by side, and then you remove the OH from the acid and then the hydrogen from the alcohol. Okay, so let's just quickly do that here. I need to clear the space first. Okay, so let's say C. Okay, OH. Alright, so let's just put the placeholders for our hydrogens. Hydrogen. Of course, you are not allowed to write it the way I'm doing. I'm running out of space, but you with your pen and the paper, you should be able to squeeze the formula inside that space. Okay. All right. So now we draw the structure of, can't even see it. Yeah, the structure of CH3COOH. All right. How do we do that? So CH3, let's just start with the easier part, the CH3, CH. So that's the CH3. Okay, now we go to a carbon here. Okay, a carbon there, right? So now this carbon has a double bonded oxygen, single bonded oxygen attached to a hydrogen. Okay, attached to a hydrogen. Okay, so it will look like that. The reason I'm writing them side by side is so that we can actually remove, okay, so that we can actually remove the OH, like I was saying. Okay, so in order for us to form this ester, we're just going to remove this part here, the OH, from the acid and the hydrogen from the what? From the alcohol. So I'm just going to remove that by erasing that part there. Okay. All right. So if we erase that part, you realize that the structure. So this is the C here. Okay, and then this bond to the other side. Okay, so that is going to be the structure. It doesn't look pretty at all. Let's go back to okay, so that's the C, then the C, because from that we removed the H and then we removed the OH. Now this combines to H2O. Okay, but that's the story for another day. Okay, it's a story for another. So this is what you should draw at the end of the day. Okay, that's what you should draw at the end of the day. Then you get the 2 marks. Okay, next the question says, name this type of micromolecule with the same type of linkage as the SS. What linkage are we talking about? So the type of linkage that we're talking about here is this guy here. Okay, we're talking about this here, where this and that link together to form this ester. Okay, where they link, they have a special name there. So the type of linkage is called a what? Okay, you have to think about it. So we have two linkages. We have amide linkage and an ester linkage. Okay, and an ester linkage. Okay, so what we're looking at there is called an ester linkage. I think it's very easy because here we're talking about esters, hence the ester linkage. Okay, linkage. So the ester linkage looks like this. You have a carbon, 2 oxygens. Since it's a linkage, it's open on both sides. Okay, So another molecule that has a micromolecule that has the same type of linkage is going to be what? It's going to be fats. Okay, fats. All right, fats, they have the similar linkage to the ester that we're looking at there. Sure hope this is the last question. Now the last question says, I hope I didn't skip anything. Vinegar contains ethanoic acid. Ethanoic acid is a weak acid. Yes, it is a weak acid. Explain the meaning of a weak acid. What is a weak acid? A weak acid, remember, it's a type of acid that partially dissociate. Okay, partially, very important. Partially dissociate in a solution, or partially ionizes in a solution. Now the question is, what are we talking about when you say something partially ionizes in a solution? All right, so let's go back to the formula of ethanoic acid. Okay, let's go back to the formula of ethanoic acid. So this CH3COOH. Okay, CH3COOH. All right, so this is ethanoic acid. Okay, so whenever you have this guy here, and then you make a solution of this guy, what's going to happen is that you have two scenarios. This hydrogen here is going to detach from this molecule to form hydrogen ions or protons. Okay, so it forms that, and then some of those molecules will remain intact. Okay, so they remain in the molecular status. Okay, so they remain as a molecule. Okay, it remains as a molecule, so you have some of that remaining like this. So this and that. Okay, now since not all of the hydrogen is dissociating or changing into these hydrogen ions, what's going to happen is that you have fewer of these hydrogen ions to attack or to react with other substance species. Okay, so remember, in acids, these dissociated hydrogens are responsible for reactions that happen. Okay, so all the reactions that occur are due to these hydrogen ions. Okay, because they're the ones that are going to be, let's say this thing is reacting with sodium hydroxide, so this hydrogen is going to displace the what? The sodium. Okay, it's going to displace the sodium there. Okay, but if you have it partially dissociating, you're just going to have fewer of these guys to be able to remove all of the, or to displace all of the sodium in that scenario. Okay, so you have fewer of those attackers to do anything in the chemical reaction. So that's what we mean by partial ionization or dissociation. Okay, so let's conclude. Remember, this is 2 marks, so you need to explain further. Okay, you need to explain further. Partially ionizes in a solution while some hydrogens remain in a molecular form. Okay, so you can also add that, yeah, but I think it's good enough for this. It's fine. I'm running out of time here. I want this paper to be around 40 minutes, not more than that. Okay, Roman figure 2, describe how it can be shown that ethanoic acid is a weak acid. How can you show that? Basically, you're just going to test, but you test with an indicator that can precisely tell you the pH. Okay, so the answer is going to be that we test with universal indicator. Okay, all right, so what are the results that we get from that? Remember, the color change for a weak acid is orange or yellow. Okay, so we expect to get orange or yellow color change of the indicator, change of the indicator. Okay. Now we can confirm. Oh, so this acid gave us orange or yellow on the universal indicator. That means what? That means it's a weak acid. Okay, it's a weak acid. Ethanoic acid CH3COOH reacts with aqueous sodium hydroxide to form salt and water in a neutralization chemical reaction. Okay, that's called a neutralization chemical reaction, where you end up with the salt and water. State the name of the salt. State the name, or let me just remove this. What is the name of the salt? The name of the salt is going to be sodium ethanoate. Okay, sodium ethanoate. How do we arrive at that? We arrive at that by looking at how the chemical reaction takes place. Okay, plus NaOH. So basically what's going to happen, remember I said this hydrogen is the one that plays a key role in the chemical reaction between what? Acids and other chemical species. So this the sodium is going to come here, and then you have the CH3COONA. Okay, now this is a sodium. So let's just break down these two guys into ions so that it makes more sense. Okay, now when you have this, when you have this guy here, we break it down to its individual ions. So that's CHCOO minus and Na plus. Okay, so this guy is a sodium ion, and then this guy is an ethanoate ion. Okay, and then when we name these ionic compounds, remember the first name is going to be the metal or the ammonium group. Okay, and then the negatively charged ion is going to be the selenium. So therefore we get our name here, sodium ethanoate. Okay, sodium ethanoate. Okay, let me just quickly remove this so that we can use it for our next question. Next question says, construct a balanced chemical equation for the reaction. Include state symbols. All right, so if we were to include state symbols, we should be able to get this 3 marks. Okay, so for the reaction, we start off with CH3COOH. This guy is going to be liquid. So ethanoic acid is liquid at room temperature and pressure, plus sodium hydroxide, NaOH, is going to be aqueous. All right, and then like I said, the sodium comes there, then the hydrogen goes there. Okay, all right, so now we get CH3COONA. Okay, so this had if this had been something like magnesium, you have the 2, you would have given the 2 to what? To this ethanoate ion. Okay, so that there's a 2 outside, and then you put brackets plus H2O. Okay, so 2 hydrogens and an oxygen, they give you H2O. H2O is a liquid at room temperature and pressure. Remember, your salts that are formed in this type of reactions are going to be what? They're going to be aqueous. Okay, I think we need to also make a minor correction here. I think this also has to be aqueous. Okay, has to be aqueous because this has been made into a solution. Okay, it's an acid after all, so this is aqueous. Okay, so I tried to make to get to all the questions in one sitting. I hope you guys managed to understand whatever I was discussing with you guys. Thank you for tuning in. I'll see you on the next video. So if you're interested, I do tutor one-on-ones. Also group classes are available. So our timetable is as follows. Wednesdays it's GC mathematics, Thursday it's GC science, then Fridays it's chemistry. Okay, so the lessons are between 9 to they are between 7 p.m. and 10 p.m. Okay, so hit us up on WhatsApp. Our number is 771-718052. So just WhatsApp us and then we can arrange for those classes. Thank you. Bye.